Exercise 905, volume of tanks and dams, is really a bit of a review of what we already covered in the prelim course. So let's go over the concepts again. So it's important to know that rain is measured in millimetres, which might seem unusual because rain is a liquid and we normally measure our liquids in mils. But really what we're measuring is the depth of water that the rain has created within a vessel. And we measure depth in terms of millimetres. So what it becomes a matter then of is calculating the volume using, if our surface or our vessel is a rectangular prism, measuring the volume of water that would have been collected, and then we can express that in terms of mils or litres in an actual vessel. The most important thing, I guess, here is the conversion, that 1 millimetre cubed, and that would be how we would record the water as it falls, say, on a roof, how we record that then in terms of the amount of water in a tank, which would be measuring in mils, is we know that 1 cubic millimetre is exactly the same as 1 mil. And so we use also our formula for the volume of a cylinder, and that is pi r squared h. Sometimes we might be estimating areas, say, and this comes evident when we're talking about, for example, a dam. A dam may not be a regular shape. So let's say we've got this rather unusually shaped dam, some straight sides and curved sides. If we wanted to actually calculate the area that the water is falling onto in that dam, then we might use an estimation using the trapezoidal rule, which just uses the area of a trapezium. Now, we saw this back in surveying. We were reminded that the area of a trapezium is half the sum of the parallel sides times the perpendicular distance between them. And remember, I said to you to try and learn that formula in its worded form, because back in when we first learnt this, the parallel sides were almost always going in that direction. Well, now the parallel sides mightn't be in that direction. As you can see here, these become our parallel sides. So rather than learn it from this figure and that always being your A and B, learn that your A and B are always your parallel sides, and sometimes they're vertical, and then the H is the perpendicular distance between them. So we could work out an estimation for the area of this shape by using two applications of the area of a trapezium. So you can see the two formulas, and substituting into the formulas and taking the calculator, and we get 2016 centimetres squared. And that would be our estimation for the area. And sometimes you get asked about your estimation. A little bit hard to tell how close it is to the real value of the area. You might get asked that at times. In this case, it's a little bit, like I said, it's a little bit hard to tell because here we're a little bit over the area, whereas on our second one, our area is a little bit under the real area. Over here, so it's difficult to say, whereas in the example for B, you can see that our estimation is going to be a little bit under here. We're going to be considerably over when we use area of a trapezium for this next situation, because you can see there's quite a dip there, but we're going to take this value or assume that our boundary is up there. And our third area is just going to be a triangle, so that's going to be quite exact. So in this case, I would think that we could make the conclusion that when we get our answer, our estimation is going to be slightly over the actual real area of this shape. Now just keep that in mind, because that is sometimes an observation that you might be expected to make, especially when these calculations are just approximations. So to get an approximate area, we're using 2 applications of the trapezoidal rule and then the area of a triangle. Nice little neat triangle there on the end. And you'll notice now that I am using more correctly an approximately equal sign, and I actually came back to this example and put approximately equal to because that's what we were asked to get, and we're getting 51 metres squared. So that's it for 905. Hopefully you'll be right to write up some summary, but it should be very similar to what you've already got in your prelim notes, and get started on this exercise.